Hello and welcome everyone back to another exciting episode of TypeScript Tips. I'm Luke, an instructor and content creator here at Covalence. I'm going to cover a fun concept called generic utility types. This is a kind of a follow-up video to the previous one in this playlist, so either find that or check for a link in the description down below. Oh my god, I said it right the first time. And you will find a link to that previous video. So make sure you watch that for some generic information on generics and their syntax and usage and things like that, and then come back and watch this video. Otherwise, we're going to cover some generic utility types to help you write, surprise, more robust, scalable, and flexible code using partial, read-only, record, and pick. For each utility, I'll define what it is, and I'll demonstrate how to use it effectively with some practical coding examples, probably flavored by my favorite TTRPG, Twitch stream/show at this point, Critical Role. So whether you're new to TypeScript or looking to level up your existing skills, then this is the video for you. But before I embark on today's mystical quest, let me invite you to join our fellowship, the Covalence Community Membership. For a mere 25 gold pieces, dollars, a month, you'll unlock an enchanted chest with coding resources, from gallant support on our Discord channel, mainly me, exclusive access to our coding challenges, aka the labs in our courses, critical help with interviews and resumes, to comprehensive scrolls courses on our front end and back end when combined together would be our full stack development course, and then my personal favorite, because I made it, my standalone React course. It's a treasure trove worth a dragon's hoard. So, as always, look down in the description below for a link to it and join us if you are so interested. Other than that, as always, start up your own TypeScript sandbox, use Code Sandbox, or just copy the repo from the link down below and start with mine. We're going to dive on in today's concept, which are generic utility types. And we're going to start with the partial type, the first utility. It is called the partial t, so you might see it shorthanded as the following. Remember, t is just for generic. It's a variable. It means type. It's a handy tool that allows us to create a type that takes every property in the given type t optional. It can be really useful in scenarios where we have a strict data structure, but we want to create a version that's more flexible. So let's take a look at that. We're going to make an interface. We're going to call it character for today's examples. We're going to have a name property with value string, a class property with value string, and a level property with value number. This is how a character will be coded in our code base. This example, name, class, and level. It's simple to it. But let's say we have this strict structure, but we only really care about the name when we're first starting our characters. So maybe as we're building out our characters and our character sheets or something like that, we need a type to represent that, hey, a user can actually fill out their name and click on the next button on the form and go to the next part and not actually have the object completely filled out. That would look something akin to the following. We have a variable we'll call new player or jester, whose name will be surprise, the value jester. Now, this is the starting object shape, and it is not quite the exact shape of our interface, but we can make a partial type. Here's how it's done. I can do a type alias, which I can say optional character. If you want information on type aliases and you've gotten this far, it's 3 videos or 4 videos ago. I'll try and remember to include a link down in the description below, and you'll find it. But type optional character is a type alias, where I can say it's going to be a partial of my character interface, and voila, I can now add that optional character property or a type alias to the variable jester. So it says, hey, as long as it has one of these inside of there, it is good to go. All right, so in that code block, the interface represents a character from my favorite show, Critical Role, and as I can see, it's defined to have a name, class, and level. However, the optional character type, where class and level are not mandatory. Neither is name. As long as one of them exists in the object, one or more of them exists in the object, it is happy. It means we're creating a new type where name, class, and level are actually all optional properties. Now, for those of you that have any TypeScript experience or have come from my full stack development, not mine, but Covalence's full stack development course, where I happen to have a lot of videos and teach a lot of it, we know there's another way we've seen this done, where you might be wondering, hey, Luke, why don't I just come over to all these properties and add the optional property syntax that does turn them all optional and achieves the exact same thing? And I'm like, well, that's really cool, but imagine 20 more properties, winky smiley face, existed on this interface. That would mean you would have to go and add 20 more optional question marks, which leaves a lot of room for mistakes and error and things like that. Whereas if you don't want to have to write 20 additional question marks or like do a control F of all colons in this object and put a question mark before them with like a find and replace, then you can now use this new technique you've learned called the partial generic utility type that allows you to do that without having to write all the question marks yourself. So that's something to keep in mind. It's important to know how that works, to know those differences, the pros and cons. For something this small, I would just go and add my question marks manually and call it a day. But in a larger, more crazy size production level scale code base, then you probably want to have this partial type in your pockets. We're going to move on now to the read-only generic utility type. Surprise, surprise, the read-only I covered a while ago in interfaces, but this bears repeating because it's also a generic utility type. Read-only type T is a powerful generic utility type provided by, surprise, TypeScript. It allows us to create a version of an existing type with all properties set as read-only. When a type is marked as read-only, it means that once a variable of that type has been created and given a value, you cannot change it. Now, keep in mind, this is a compiler-only tool and not a runtime tool. This will help you prevent errors from getting to the browser, but it won't. Of course, I forget to zoom in. That zoom in one level hopefully didn't make it too bad looking in the first part of the video, but since I zoomed in, hopefully it's better now. People are squinting their eyes at the screen. Yeah, so we have this same interface of name class level. Let's go ahead and change it up a little bit, and we'll say we'll have const vexalia be a read-only type of my character interface, and we're going to assign it the following. It's got to have a name of vex. Well, the name doesn't matter as long as the name property is there. She's going to be a class of ranger, and we're going to put her at level 10 for today's information, about halfway through the game, I guess, or the series. So in this example, we have our character interface once again, but this time we're creating a variable vex that is a read-only character type, right? And we do that with my lovely little syntax right here. Remember, the character is this T that's getting put into the read-only generic utility type here, right? So now that we've done that, what this means is I cannot come down here and say, hey, Vex is leveled up to a new level of 11. I get a compiler error that does say, cannot assign level because it is a read-only property. This will prevent us from making errors in our code if indeed this object of information is meant to be only read and manipulated and not actually assigned new values, right? So it's read-only. Now, again, I need to stress this. This is not a runtime prevention. If I tell the TypeScript compiler to ignore this error and put it to runtime, this will still work. It will still take Vexalia's level and change it from 10 to 11 in the browser or whatever our runtime environment happens to be. This is Node, for example. It will still run this code, and it's going to work. This is fine JavaScript code, but in TypeScript land, the compiler is telling us you probably didn't mean to do this because you specify this is a read-only character. That is the advantage and usefulness of the read-only generic type. Now, moving on to, let's change this to, we can leave it as an interface. Let's start messing with other types and things like that here. I've been saying it so much, I might as well assign it as a character type right here. I could leave it as an interface, whatever. Let's change it up a little bit. No reason I did that, just for funsies, just to show y'all it can also, it's not just an interface only thing we're working with here. I want to make sure y'all aren't thinking it's an interface only thing you can do. Remember, types can also be objects. They're like interfaces. I have a video for that if you want to go watch it in this playlist. Anyway, we're moving on to the next one, which happens to be record, and you see this a lot with K and T as the two types that are added to it. So, the record KT utility type allows us to create a new type with specified property keys and the same type of value. It's a way of mapping the properties of an existing type to a new type. Let me show you what I mean by that, because I think taking it and trying to describe it, even I didn't like that definition too much from the TypeScript handbook, kind of transmogrified into my own words there. It's a fun word. We'll say something like this. We'll say we have 3 characters that are going to be coming up here in just a moment, and it's going to be a record generic utility type of the following. It's going to have a property called character1. It's going to have a property called character2, and it's going to have a property called character3. So this will allow me to now, and it needs to be of type character. So yeah, that's what it was. A record of those types of these new properties, right? And they're all going to follow this type. So the K is like this multiple properties of our new object, and each property will have a data structure of our type character right here at the end here. So again, this could have been interface. I'm pointing out that it doesn't matter which one you use. So that's what we're looking at here in our code base. What does this mean in the terms of a code example? I can now have, let's say, a list of characters that will be of the 3 characters type alias that will have a property called character1 that must follow the structure I designated for characters up here that have a name, Vaxeldan, class, rouge, level, we'll say 10 for this demo. Who cares what the level actually is at this point? And I have to have another property of character2. We'll do his sister, Vex. She'll be level 11 for today, this example. And then finally, we have to have a character 3 that is going to be Grog, Barbarian, too lazy to write Barbarian, at level 9. So there you go. Now TypeScript is happy because I said that the 3 characters type will be a record of an object that will have properties character1, character2, and character3 that will all follow the structure of my character type. This makes it so, again, these 3 objects inside of here must match my character type. These 3 properties in this new record, if you will, are all these values here. That's where that correspondence happens to be. So in the characters object, we had to provide 3 properties, character1, character2, character3. Those are the keys specified in our new record. Each of these keys must map to the character object. So that's what the record does. New keys, aka the K, I should have probably said at the beginning, new keys mapped to this type. We're keeping a record of these keys that will follow this type structure. That is the association you want to keep in mind for records, right? So we have what each record should look like, and now we're saying this is what the record structure is going to look like, and voila, we have it now being consistent. So if I remove character 3, it gives us an error saying, hey, this has to have a character 3 property on this record. If I change it from just Grog to, or just name Grog, it says, hey, character 3 does not match the character type because it's missing the properties of class and level. So it's extremely useful when you need to have a consistent shape for your object and you want to ensure that all properties in that object adhere to the same type. Beautiful stuff to know how to do. And that rounds it out to our final one, which is our record, or not from our record to our pick of type and keys right here. So this utility type allows us to create a new type by selecting a subset of properties from an existing type. So if record made us stick to a structure, it sounds like this one might let us pick our structure based off a given type as is. So I can say type character, name, and class, but I don't care about level, can be a pick of the following type of our character type, with the keys of name and class being the ones we care about from the character type. So now I can have a code example, sticking with Critical Role. I can say const key is going to be of type character, name, and class, and assign a value of name keylith. Pretty sure that's how it's spelled. You think I would know considering how much I've watched it. And a class of druid. Right there, it is all fine and dandy, right? The object, the keylith is an object of type character, name, and class. We're able to assign the name and class properties, and TypeScript will enforce this. Any attempt to add an extra property or omit one, for example, will end up with errors saying, hey, this object structure needs to have the properties of name and class with the appropriate types that they have up here, aka string values. If I try and add her level of 20, that's also going to get angry at me because it says, hey, level is not part of the structure that you are picking from the character type. So it helps me enforce these more tailored types. So it allows us to create tailored types, like pick and choose what we want, only contain the properties we're interested in, making our code cleaner and ensures that we're working with exactly the data that we need, right? So that's a wrap on our grand tour through TypeScript generic utility types. I've used a ton of Critical Role information, so go check that out if you're curious as what it is. If you're a fan of tabletop RPGs or want hundreds of hours of content to watch or listen or binge in the background, I do recommend it. I'm not sponsored by them in any way. I'm just a huge fan. I've taken all these hopefully abstract ideas and shown you some simple practical examples to use with them here to make your code, #meme, more flexible, more readable, and more type safe. We embarked our journey with the partial type, turning all properties into optionals, which is a faster and easier way to do it than adding question marks all over the place. I then armed y'all with the read-only type, which made attributes unchangeable once defined. Again, remember, a lot of these are TypeScript compiling time only and not runtime. The JavaScript code could still work incorrectly, but you need to listen to your compiler. Don't just ignore these errors. We then continued the journey with our record type. That was the K for keys, comma T type, where we assembled an entire roster of unique characters that says, hey, I'm going to have a record object of these properties that will all follow this structure. And then finally, I deployed the pick type, which of type, comma, K, or keys, letting us choose only the characteristics we needed for a specific scenario. So that was allowing us to pick and choose properties, right? Whereas the record enforced all the properties on another object structure. These are all versatile tools. They're very practical instruments in our coding toolkit, and they're going to pave the way for you to be a TypeScript expert, or at least be able to read other people's TypeScript code and not get hit with that wave of imposter syndrome when you go from a JavaScript background to a TypeScript code base or like a code base on a team, and you see all these crazy keywords and have no idea what they mean. Hopefully this series is like a awesome little glossary dictionary definition to help y'all not get overwhelmed with imposter syndrome like I did going to my first TypeScript to TypeScript code base. So I hope you all found this useful. Please show your support with the thumbs up. Share your comments, your thoughts, and your experiences in the comments down below, or any questions or ideas for future videos you want to see. If you haven't already, make sure you hit the subscribe button to keep up to date with all my awesome TypeScript type series, as well as all the awesome videos we put out here on the Covalence channel. And thanks again for joining in this episode. I'm your host, Luke, and I hope you all enjoyed it. And until next time, happy TypeScripting.